and it's called about a remarkable number. Yes, I think we lost them as well. Oh no, they're here. Okay. Yes, you have the right to be presentation. You can download yours.
Okay, good. So, hello, we're going to present a problem called remarkable numbers. We are Avurvări Maria,
Dana, Claudia,
Andrei, and Alex.
We are from the National College IASI, Romania. This is our first time participating in the MATH.en.JEANS workshop, and now we're going to start our presentation.
The problem. A number is called remarkable if there exists a multiple of it that is written in the 10th place as a string of the digit 9, followed or not by a string of the digit 0. For example, we had to answer if the number 3 is remarkable and to justify why it is or it isn't. We also had to answer what are the remarkable numbers lower than 6 and what are the remarkable numbers in general. As a mathematical definition, an integer x other than 0 is called remarkable if there exists a multiple of it noted with mx as a string of the number 9 multiple of times, then the digit 0 multiple of times, or the string of the digit 0 can also be inexistent.
So, is 3 a remarkable number and why? 3 is a remarkable number because there exists a multiple of 3. 3 times 3 equals 9, with m equals 1 and n equals 0. 2. Which numbers smaller than 6 are remarkable? The remarkable numbers that are smaller than 6 can be divided into categories: positive integers and negative integers. Which numbers smaller than 6 are remarkable? 1, 2, 3, 4, and 5 are remarkable numbers because there exists multiple of 1. 1 times 9 equals 9, with m is 1 and n is 0. Multiple of 2. 2 times 45 equals 90, with m equals 1 and n equals 1. Multiple of 3. 3 times 3 equals 9, with m equals 1 and n equals 0. Multiple of 4. 4 times 225 equals 900, with m equals 1 and n equals 2. Multiple of 5. 5 times 18 equals 90, with m equals 1 and n equals 1. Note that the specified multiples are not unique. To determine all negative integers that are remarkable numbers, the general form of the remarkable positive numbers will be determined later.
3. In general, which numbers are remarkable? All positive integers are remarkable numbers. Proof. We will prove that any positive integer x has a multiple of form 999 taken of m times, followed by 000 taken of n times, with m and n unspecified. Remark 1. Finding x, an integer x different from 0, remarkable, for which there exists a multiple with the form a multiple of x equals 999 taken of m times and 000 taken of n times. That equals 9 multiplied by 111 taken of m times, multiplied by 2 to the power of n, multiplied by 5 to the power of n, with n a positive integer and n a positive integer. Is like looking for the divisors of the number 9 multiplied by 111 taken of m times, multiplied by 2 to the power of n, multiplied by 5 to the power of n, using the divisibility criteria in number theory.
Statement 1. For all n1 numbers which are natural, all n2 numbers which are natural, and all s numbers which are natural, the numbers 2 to the power of n1 multiplied by 5 to the power of n2 multiplied by 3 to the power of s are remarkable numbers. Proof.
Sorry, excuse me. There is a problem with the presentation. We only see the slide from the beginning.
Sorry, excuse us, we can't hear you too well. If you could repeat what you just said.
We had a problem with the presentation. We only see the first slide.
Can you write in the chat, please? That's not real.
Probleme cu slide-urile. Nu au văzut decât primul slide. Okay. Ați dat slide-uri? Hai să ne întoarcem.
Să știți că nu s-a scris înainte de să ștergeți. Stop sharing.
Hai.
Și acum începeți din nou.
Hai, din nou.
That's not so.
Nu, e ok. Dar ce aveți tot timpul în față? Orice. Nu începeți din nou. Începeți din nou. Ok.
Te dau share? Da? Și share sistem audio?
Can you see now the other slides?
Yes, perfect.
Okay. Should we start from the beginning or should we continue?
Maybe you can have like a quick resume from the beginning.
Yeah, sure. We will do a quick recap right now. Okay, so we will start again from the problem.
So, a number is called remarkable if there exists a multiple of it that is written in the 10th base as a string of the digit 9, followed or not by a string of the digit 0. And for example, we had to answer if the number 3 is a remarkable number, and to justify why it is or it isn't. We also had to answer if what are all the numbers lower than 6. And lastly, we had to answer what are the remarkable numbers in general. And as a more mathematical definition, an integer x other than 0 is called remarkable if there exists a multiple of it noted with mx that can be written as the digit 9 multiple times, followed by the digit 0 multiple times.
So the first question is 3 is a remarkable number, and why? 3 is a remarkable number because there exists a multiple of 3. 3 times 3 equals 9 with m where is 1 and n is 0. And which numbers smaller than 6 are remarkable? The remarkable numbers that are smaller than 6 can be divided into categories: positive integers, 1, 2, 3, 4, and 5, and negative integers. Which numbers smaller than 6 are remarkable? 1, 2, 3, 4, and 5 are remarkable numbers because there exists a multiple of 1 times 9 equals 9 with m where is 1 and n is 0. Multiple of 2 times 45 equals 90 with m1 and n1. Multiple of 3 times 3 equals 9 with m is 1 and n is 0. Multiple of 4 times 225 equals 900 with m1 and n2. And multiple of 5 times 18 equals 90 with m equals 1 and n equals 1. Note that the specified multiples are not unique. To determine all negative integers that are remarkable numbers, the general form of the remarkable positive numbers will be determined later.
General, which numbers are remarkable? All positive integers are remarkable numbers. Proof. We will prove that any positive integer x has a multiple of form 999 taken of m times, followed by 000 taken of n times, with m and n unspecified. Remark 1. Finding x, an integer, with x different from 0, remarkable, for which there exists a multiple with the form multiple of x equals 999 taken of m times, followed by 000 taken of n times, equals 9 multiplied by 111 taken m times, multiplied by 2 to the power of n, multiplied with 5 to the power of n, with m and a positive integer and n a positive integer. It's looking for the divisors of the number 9 multiplied by 111 taken to the power with m, multiplied by 2 to the power of n, multiplied with 5 to the power of n, using the divisibility criteria in number theory.
Statement 1. For all n1 numbers which are natural, all n2 numbers which are unnatural, and all s numbers which are natural, the numbers 2 to the power of n1 multiplied by 5 to the power of n2 multiplied by 3 to the power of s are remarkable numbers. The proof is for all n numbers which are natural, there exists mn equals 111 taken m times, multiplied by 9, multiplied by 2 to the power of n, multiplied by 5 to the power of n, which is a multiple of 2 to the power of n, multiplied by 5 to the power of n. And out of our curiosity, we used the scientific workplace program for the decomposition into prime factors for 111 taken m times, for m between 1 and 81. Here are some of the examples. Some of the more notable ones are m equals to 19, which is prime, with m equals to 23, which is prime, and which will also be some of the prime factors. And when m equals 71, the scientific workplace program did not work. And when it was 73, also didn't work, probably because of the big number of prime factors.
Heuristic 1. For all s, which s is a positive integer, the number 3 to the power of s divides 111 taken 3 to the power of s times. Using mathematical induction, we will prove the divisibility statement. Let Ps be a proposition which states that 3 to the power of s divides 111 taken 3 to the power of s times for all s positive integers. Obviously, P1 is true, that is the basic step, because 3 to the power of 1 divides 111, which is 3 multiplied by 37. So, in the next step, we can assume that Pk, which states that 3 to the power of k divides 111 taken 3 to the power of k times for all k positive integers. Then there exists d, a positive integer, such that 111 taken 3 to the power of k times can be written as d multiplied to 3 to the power of k. Let us prove that p of k plus 1 is true. That is the induction step. P, k plus 1, states that 3 to the power of k plus 1 divides 111 taken as 3 to the power of k plus 1 times. We observe that the number 111 taken 3 to the power of k plus 1 times can be written as 111 taken to 3 to the power of k times. 3 times, obviously. So we can write it as d multiplied by 3 to the power of k, multiplied by 10 to the power of 3 to the power of k, multiplied by 10 to the power of 3 to the power of k, plus d multiplied by 3 to the power of k, multiplied by 10 to the power of 3 to the power of k, plus d multiplied by 3 to the power of k, multiplied by 1. So if we take out the common factor, we obtain that d multiplied by 3 to the power of k, multiplied by 10 to the power of 3 to the power of k, multiplied by 10 to the power of 3 to the power of k, plus 10 to the power of 3 to the power of k plus 1, is the actual remainder. Using the rule of divisibility by 3, since the sum of the digits for that number is 3, we obtain that there exists d prime, a positive integer, such that that number is divisible by 3, and we can write it as d prime multiplied by 3. Then there exists d multiplied by d prime, a positive integer, such that 111 taken 3 to the power of k plus 1 times is d multiplied by d prime multiplied by 3 to the power of k plus 1. So we proved what we wanted to prove, that 3 to the power of k plus 1 times divides 111 taken to 3 to the power of k plus 1 times for all k positive integers. So the induction is complete, and by the principle of mathematical induction, the statement is true for all positive integers.
Okay, now the second statement. All prime natural numbers greater than 5 are remarkable numbers. We verify that every prime number greater than 5 and lower than 100, 7, 11, 13, and so on, is a remarkable number because x divides the digit 1 a number of times with m that's not unique. And here we got some examples. For instance, for the number 7, we have more than 10 examples to prove that the number 7 is a remarkable number. As for numbers such as 97 or 61, we've only found one example, but they're still remarkable numbers.
Okay, then we wrote the number 111 taken m times as the sum of 10 to the power m minus 1 plus 10 to the power m minus 2, so on, plus 10 to the power 2 plus 10 to the power 1 and plus 10 to the power 0. And we will analyze a few examples so that we can find the rule to write m depending on prime number with p bigger than 5, such that p divides 111 taken m times. For example, p equals 19. When we divide the powers of 10 by p, we will obtain the following remainders. For 10 to the power 0 with 1, for 10 to the power 1 is 10, and so on. And then we made the sum of them and observe that is a multiple of 19. So m, the numbers of 1 in the first number, is a multiple of 18. We take another example, p equals 7. When we divide the powers of 10 by 7, we will obtain the following remainders. For 10 to the power 0 is 1, for 10 to the power 1 is 3, and so on. And then again, we made the sum of them and observe that it is a multiple of 7. So m is a multiple of 6. And we repeat this process for other examples. And at the end, it can be assumed that in general, m is a multiple of p minus 1.
Our third statement is that for all alpha positive integer and all prime numbers, p positive integer that is different from 0 with p greater than 5, the numbers p to the power of alpha are remarkable numbers. As my colleague previously said, we try to decompose 1111 written m times to a sum of the powers of 10. And so we have the sum is 10 to the power of m minus 1 plus 10 to the power of m minus 2 and so on, till we get to the 10 to the power of 1 and finally 1. We try to demonstrate that a prime number p to the power of 2 is a remarkable number for any p greater than 5. And as our example, we took p equals 7, and thus 7 to the power of 2 is 49. And we applied the same rule as before. With our program, we tried to find the reminders. And what's curious about this case is that the reminders repeat themselves every 40 times, which can be written as 7 multiplied by 6, or as a p form, p multiplied by p minus 1. And using our program again and again to find for other prime numbers such as 11 and 13, we found out that our intuition is right, and we obtained the same rule. So we said that p to the power of 2 divides 111 written p to the power multiplied by p minus 1 times. And with this, we had some kind of intuition that p to the power of 3 might somehow divide 111 written p to the power of 2 multiplied by p minus 1 times. And again, with our program and doing experiments and analyzing cases, we found that that is true. And by the last 3 things that we presented, we concluded that any p prime number greater than 5 at the power alpha, that is a positive integer different from 0, divides 111 written p to the power of alpha minus 1 multiplied by p minus 1 times. And thus we found out that the power of prime numbers are remarkable.
Okay, statement 4, for any a1, a2, and so on, k positive integers, and any prime number p1, p2, and so on, pk greater than 5, the numbers p1 to the power a1 multiplied by p2 to the power a2 multiplied by so on multiplied by pn to the power an are remarkable numbers. So we found out that this is true because using what we found here, that p to the power a divides 111 taken a multiple of p to the power a minus 1 multiplied by p minus 1. And because the numbers are prime, that means that if p1 to the power a1, p2 to the power a2, and so on, pn to the power an, divide the 111 taken a multiple of p1 to the power a1 minus 1 multiplied by p1 minus 1 multiplied by p2 to the power a2 minus 1 multiplied by p2 minus 1, and so on, multiplied by pn to the power an minus 1 and multiplied by pn minus 1. That means the product of these numbers divides 111 taken this multiple of this number.
And now we have a conclusion. In conclusion, after analyzing all the possible cases, we can see that every integer, positive or negative, is a remarkable number because we were able to find a multiple of it written as a string of 9, followed or not by a string of 0.
Thank you for your attention.
Thank you.